Hey everyone, welcome back to my channel. So today we are going to learn about what is data. So have you ever wondered that what fuel does the machine learning algorithm requires? As you know that vehicle requires like fuel as a gasoline, diesel, biodiesel, CNG, LPG or any other fuel, okay? But what fuel does the machine learning algorithm requires? So it is the data. And no matter how advanced your machine learning algorithm is, but if you don't have a good enough data, then it may not perform well, and that is fact. Okay, and everything around you is a data. Okay, the temperature inside the room or your outside the room is a data. The fan speed is also a data. Then heartbeat, okay, it is also data. Then for example engagement. So suppose 150 people are watching this video tomorrow at 8 p.m. It is also a data. Then the dog barking in your neighborhood, okay, at certain frequency, sound frequency, it is also a data. Then the rainbow colors, it is also data. So universe is drowned in the data, and you need the right tools to listen that data. So where does the data come from? Okay, data come from the variety of sources, but for now I have mentioned four major sources. The first is the sensors. So like thermometers, cameras, microphones, accelerometers, gyroscopes, they generate a lot of data. Okay, these are the sources of data. Then the human behavior. Suppose you are rating a movie, then you are rating the food on the food delivery app. You are answering yes or no on the poll. You are the typing comment. Okay, that is generating the data. Then the third example is transactions. So for example, you are buying the t-shirt online, okay, and you made a purchase. So that data is also recorded. You are swiping your metro card, okay, at certain time at the metro stations. That is also recorded. If you are surfing a website, your whole journey is recorded. That is also data. Then the fourth one is simulations. So for example, suppose ISRO wants to launch a mission to land a rover on the Mars. Okay, so before that, they have to generate a lot of simulations, and which will be generating a lot of data, which will be helpful in that mission. So simulations is also generating a lot of data. The third one is, can we measure everything? The universe has infinite data, but we cannot measure everything. So, for example, you are walking into a massive library which is having millions of books about health, and you pick up the one book that is the benefit of drinking water, and you confidently declare after reading that you know everything about health. But that's exactly what happens when you collect the data. Okay, so you are not capturing the whole story of the data. Okay, you are assuming that you know about everything, but the whole story is not captured. And the other examples are, for example, you measure a room temperature, that is for example 25 degrees Celsius, it is recorded, but you ignore the humidity, air quality, wind speed, so you are missing the data. Then you are tracking how many steps you walk, okay, but you are not tracking the sleep quality, the stress level, then you are missing the actual data. Then you count the email replies, but you miss whether the people send those replies, okay, with whether they are happy, angry, or in a sarcasm way. Okay, so data can be missed. We cannot capture everything. So is the data perfect? The answer is no. Data is not perfect. And here are the 6 reasons that I mentioned why data is not perfect. So for example, the actual room temperature is for example 26 degrees Celsius, and the thermometer reads 24 degrees Celsius. So it includes the noise, okay? Maybe that due to some electrical interference or any other factor. Then the second reason is biased, okay? So you are collecting the weather data, but you are collecting only from one or two locations, not from every locations. Then you may not capture the whole story of the data, and the data becomes the biased, okay? Data is biased. Then missing values. Okay, so you are capturing certain parameters from a field location where the machines are located via IoT sensors. Okay, and those IoT sensors stop sending the data since 3 days. So you may miss some important events. Okay, that may have happened. So that is a missing value in the data. Then wrong labels. So accidentally you are labeling cat as a dog or dog as a cat. So that is a wrong labeling. Then, for example, you are tracking study hours for from the students using the app. So most of the students gets logged in and logged out, and the duration is like 2 to 4 hours. Okay, so but one of the students forgot to logged out. Okay, and he logged out next day. So your app recorded 25 hours. Okay, that is a wrong error in the data. That is outlier. Okay, then the sampling error. So you are surveying only the engineering students about their career choices, and you conclude that everyone's want to be a software engineer, but that is totally wrong. You never ask the artists, doctors, or chef. Okay, so data is not a perfect, and it is real messy. Okay, so ML models are only perform well. Okay, ML models only perform well when a good data is fed to them. Otherwise, they can make a dangerous prediction. So the noise versus the misleading data. So what is noise? So for example, you are following a same route every day and you are tracking the daily steps. Okay. So for example, if there is a small random variation in your steps, then you can consider it as a normal noise. But if there is a large variation in that data and you feed it to the machine learning model, then the model may think that Tuesday requires more walking than Mondays. So it is predicting the wrong things. Okay, so because it the way the model is trained on the noisy data, so that is the reason. The second is the misleading data. Okay, so for example, the student who owns the calculator score higher on mathematical test. Okay, sorry, mathematics test, and you conclude that students should buy the calculator to improve the grades, but that is a false correlation. The real cause is that the students were serious about their mathematics test. Okay, and they buy the calculator and they study more. Okay, so you should always ask what's hidden behind the data. Then comes the limitation of the data, the four deadly sins. Okay, so the first is the data may be incomplete, you may not capture the whole story. Okay, then the second is the data is biased. Okay, so for example, you are figuring out the grades that student received, okay, in the class, and you only collected those data in which the student scored above the average. Okay, so data can be biased. Then the third is outdated. So for example, you are training the machine learning model from the data from the year that is 2018 or maybe 2020, and when you deploy it to the production, then it may predict, it may do the wrong predictions, and the reason is you have not trained it on the latest data. So that's why the data can be outdated. Then the fourth is the manipulated data. So for example, the fake reviews bots then generating the fake user behavior. Okay, so this is the manipulated data. So these are the limitations of the data. Then the key takeaways for the ML students. The first is that data is everywhere, but we can only measure those things for which the measurement devices are made. Okay, then the second is data come from sensors, human behavior, and it may lie sometime. Okay, so you should not trust the data blindly. You should always ask who collected it, how, when, and why. Then the third is data is never perfect. It may include noise, bias, gaps, errors. Okay, and they are not bugs but the features of reality. Then fourth is your model will believe everything you feed it. Okay, so if you feed the misleading patterns, okay, if you give the misleading patterns to the machine learning model, then it might do the dangerous prediction, it will make the dangerous predictions. Then the fifth is, the goal is not to get the perfect data, okay, but data must be good enough to make a smart interpretations, okay. So as a ML student, you should know about what is missing, what is broken in the data, and how can you fix it. So the final thought is, be a data detective. You are not just training the machine learning models, okay. So that is easy to learn, okay, if you know about the machine learning algorithms, the mathematics behind that, so you can directly train the models. But the actual thing is, you should know about the data, okay, the real story behind the data. So you should be acting as a forensic scientist and analyzing the crime scenes made by the numbers, okay. So you should ask yourself before training any machine learning model, so what did you measure, then what did you miss in the data, and what maybe the data is lying, okay. So, and is the correlation in the data is correct or not, or it is just a noise in the data, okay. So great ML engineers don't just code, they question, and that's it.